All right, so we're going to take a look at this. Some of these problems were addressed back in the inverse trig functions category, and somebody reached out to me and said, hey, can you help us out with some of these problems? Well, so 13 through 16 were the issues. 13 and 14 are very similar. The only difference is this one is an arc sine function, this was an arc cosine function. So they're very similar. But the one thing that we want to understand is about when it comes to solving equations, we want to reverse the order of operations. The order of operations is for evaluating. So we're going to reverse that. And with this then, I'm just going to rewrite this down. So we have arc sine of the quantity 7x minus pi equals 1 over 10. All right, so we want to get x by itself. So another way to think about solving an equation is like you was opening up a present. So the present's on the inside, and you got to get rid of all the things on the outside before we can even play with it. The x is our present. That's our toy that we want to get to. So we need to take away all the stuff on the outside, remove everything, and then be left with x at the end, just like you do when you open up a present. You want to be left with the toy that you get. So to get rid of the arc sine, we need to do the inverse of arc sine. Well, the inverse of arc sine is sine. That's the idea. So we're going to do the sine of both sides. Well, that's going to leave us with 7x minus pi equals the sine of 1/10. So these two are inverses. That means the input becomes the output. Now we want to get the x by itself. And so, again, what we want to deal with is the stuff farthest away. We want this minus pi, or the subtraction and the addition. We want to get rid of that. So to undo that, just like you would back in elementary school, you would just, or middle school, you would add the pi to both sides. So now we're at 7x equals pi plus the sine of 1/10. And the last step then would just be to divide by that 7. And so the similar idea for number 14 is the basic same concept, but we're going to use cosine instead. So that's the idea right there. Now, 15 and 16, very similar problems. You're given a triangle in both cases. You're given where theta is going to be by your source, whether it's the person or whether it's the police car. And so it doesn't matter whichever one we pick. They're basically it's the same concept. So we'll just go with this one here because both of them say write theta as a function of x is the idea. We want to. So there's two ways we could go about this. So if you have your angle and your fraction, this is what connects trigonometry together, the angles and the fractions. So if we want to go from angles to fractions, that's when we do the trig function itself, meaning sine or cosine or tangent or even cotangent or cosecant or secant. From the angle to the fraction, we use these. To go from the fraction to the angle, we would use the arc. So arc tangent or arc cotangent or whatever it is. So it's always the arc when we go from the fraction to the angle. So if we want to get the angle, that's theta. And so we want theta by itself. This is right here. That's our angle. And so that's going to be theta all by itself. And so we need to use the arc function. And so it's going to be arc whatever. So here's the angle, and we have h and we have x. So h is the opposite side. X is your adjacent side. And so the relationship between opposite and adjacent, we're given a couple options. Either we're going to say tangent would be opposite over adjacent, but if you did the reciprocal, which would be cotangent, that'd be adjacent over opposite. So there are more than one correct answer to the original prompt, but we just have to look to see which one actually fits what we're doing here. So because we want to get to that theta, we're going to use one of these arc ones. So now if it was arc tangent, or we can say theta would be arc cotangent. And so then we have to look at, so arc tangent, we say, hey, opposite over adjacent. The opposite of theta is your h right there. X is your adjacent. Or the arc cotangent would be the adjacent over the opposite. X is our adjacent over H. Now, so with this is just based off of here. Typically, when you want to go about these problems, it's going to make it a lot easier for us in calculus is to leave the X in the numerator is really what we want to do. But it doesn't matter. Now, in this case, we're also told up here that we're flying at an altitude of 14 miles, which means that H is 14. So we can either, really update this. So we get theta equals arc tangent of 14 over X, or we have theta equals arc cotangent of X over 14. So either one of these would work. 2C's an arc cotangent. So we can see right there, we have arc tangent, that says 14 over X, that says X over 14. So we're going to have to go with one of these arc cotangent ones. And the order is incredibly important. And so we want to make sure we're paying close attention to those things. So just be careful about that and we'll be good to go. All right, so hopefully that helps you out.